Today we are going to discuss the topic preparation of carboxylic acids. Before discussing preparation of carboxylic acid, we discuss structure of carboxylic group, that is COOH group. In carboxylic acids, the bonds to the carboxylic carbon lie in one place, and these are separated by an angle of 120 degree. That means all the bonds in carboxylic carbon lie in one plane. In the same plane, all the bonds are located, and these bonds are separated by an angle of 120 degree. And the second point is, this carboxylic carbon is less electrophilic than carbonyl carbon. That is, carboxylic carbon, that is the carbon present in COOH group, is less electrophilic than carbonyl carbon, that is CO carbon, because of the resonance structure of carboxylic group. Okay. Let us see the resonance structure of carboxylic group. In the first structure, we can see that the double bond of carbonyl carbon is shifted to oxygen atom. So in structure 2, you can see that that double bond is became a negative charge. Okay, and in second structure, that carbon gets a positive charge that we discussed earlier, that means electrophilic nature. Okay, now we can see in the second structure, the one lone pair from OA oxygen atom is shifted as a bond, and it forms a bond between carbon and oxygen, and we get a double bond. But we can see in the structure 3. So the positive charge of carbon is disappeared, and oxygen gets a positive charge, and the negative charge of the other oxygen is still there as it is. That means the positive charge in the second structure is disappeared in the third structure. That's what we discussed earlier. That means electrophilic nature of carboxylic carbon is lesser than that of carbonyl carbon, because there is no positive charge in the third structure. So due to the resonance structure of carboxylic group, the electrophilic nature of carboxyl carbon is lesser than that of carbonyl carbon. Okay. Now we are going to discuss the preparation of carboxylic acids. First we discuss the preparation of carboxylic acids from primary alcohols and aldehydes. Primary alcohols are easily oxidized to carboxylic acids with very common oxidizing agents such as potassium permanganate in neutral or acidic or alkaline media, or in the presence of potassium dichromate, that is K2Cr2O7, and or the presence of chromium trioxide, that is CrO3, in acidic media. This chromium trioxide, that is CrO3, in acidic media, that means in sulfuric acid, CrO3 in H2SO4 is known as Jones reagent. That is very important. CrO3 in in acidic media is known as Jones reagent. So there are two equations. So there are two reactions. RCH2OH in alkaline KMnO4 gives RCOOH. Here that CH2 group is there in the reactant. So that entire portion converted to COOH. That means it is oxidation. Okay, it means removal of hydrogen. Oxidation is nothing but removal of hydrogen or addition of oxygen in terms of hydrogen and oxygen. Okay, so as we all know what is reduction, oxidation, such things, so we are not going very deeply about this oxidation and reduction, but we will see this only. And the second reaction, that is the compound 1-decanol is oxidized to decanoic acid in presence of Jones reagent, that is CrO3H2SO4. Okay. Now we can see the preparation of carboxylic acids from alkyl benzenes. Alkyl benzenes are benzene with alkyl group. That means there is an alkyl group attached to benzene ring. Example, methyl benzene, ethyl benzene, propyl benzene. These are the examples of alkyl benzene. Here we discuss the preparation of carboxylic acids from methyl benzene. Methyl benzene is otherwise known as, it is also known as toluene. So in the first reaction, toluene, that is an alkyl benzene, on reaction with KMnO4 in presence of an alkali, that is KOH, and heat, it converted to potassium salt of carboxylic acid, that is the intermediate reagent, that is benzene ring along with COOK, that is known as potassium salt of carboxylic acid. This potassium salt of carboxylic acid undergoes hydrolysis to form benzoic acid. So in this reaction, toluene reacts with the potassium permanganate in an alkali, that is potassium hydroxide, to form potassium salt of carboxylic acids. And this potassium salt of carboxylic acid undergoes hydrolysis, or on hydrolysis it gives carboxylic acid. And irrespective of the alkyl group present in the alkyl benzene, it is converted to COOH group. എന്ന് പറഞ്ഞാൽ CH3 അല്ലെങ്കിൽ CH2 CH3 ആണെങ്കിലും എല്ലാം COOH ആയിട്ട് തന്നെ മാറും. So we can take another example. It is not given in this slide. That is, ethyl benzene can also react with the KMnO4 and KOH. It also gives the same, followed by hydrolysis, it also gives the same compound, that is benzoic acid. So methyl and ethyl benzenes undergo this reaction to form benzoic acid only. No other product is formed. Okay, that is all about the preparation from alkyl benzenes. Now we are going to discuss the preparation of carboxylic acid from amide. Amides are a different functional group, that is CONH2 group. Amides are CONH2 functional groups. So benzamide, here we discuss the preparation of benzoic acid from benzamide. Benzamide is benzene ring along with the CONH2 group. This benzamide undergoes acid hydrolysis. This benzamide undergoes hydrolysis to form sodium benzoate. After hydrolysis, we get sodium benzoate. This sodium benzoate, on reaction with dilute HCl, you get benzoic acid. So benzamide can be converted to, or from benzamide we can prepare benzoic acid by hydrolysis. Okay, that is all about the preparation today. Okay, this is your assignment. There are 4 structures. You have to write the IUPAC names of the following 4 compounds. Write the IUPAC names of the 4 compounds. That is all about our session. Thank you.